Hello, my name is Fritz, and in this tutorial we are looking at the determinants of a 2 by 2 matrix. Let us consider the matrix shown below. It has two rows, row 1 and 2, as well as two columns, column 1 and column 2. So it is a 2 rows by 2 columns matrix and written as 2 by 2. Read 2 by 2 matrix. Recall that a matrix is a rectangular array of numbers. You can think about the rows in your classroom as well as the columns in your classroom. The diagonal line that passes from the top left to the bottom right of the matrix, from top left to bottom right, is called the leading diagonal as shown. The leading diagonal. However, the line from the top right to bottom left is the reverse or off diagonal. The reverse or off diagonal. The determinant of a 2 by 2 matrix M, denoted det M or absolute M, is the product of the leading diagonal entries minus the product of the reverse diagonal entries. That is, the determinant of M is equal to, for example, taking this case, the leading diagonal entries we have 2 and 1, that is 2 times 1, minus the off diagonal entries giving us 3 times 4. So the difference of these products gives us the determinant of the 2 by 2 matrix. So we have 2 minus 12 giving us minus 10. Therefore, the determinant of this matrix shown is minus 10. Generally, for any 2 by 2 matrix M, where M is equal to A, B, C, D, the determinant of M is given by AD minus BC, where AD is the product of the leading diagonal entries and BC is the product of the off diagonal entries. Let us take some examples. Find the determinants of the following matrices. We have A having entries 4, 1, 3, 2. Here I've specified the leading diagonal with red and the off diagonal in blue. So the determinant of A will be given by the product of the leading diagonal with entries, that is 4 times 2, minus the off diagonal 1 times 3. When we simplify, we will have 8 minus 3 giving us 5. Therefore, the determinant of matrix A is 5. Let us take another example of B. B has entries 0, 1, 5, minus 2. So the determinant of B will be given by the product of the leading diagonal, that's the blue entries, 0 times minus 2, minus 1 times 5. When you simplify, we will have 0 minus 5 giving us minus 5. So the determinant of B is minus 5. And now for M, having entries minus 4, 1, 8, minus 2, we will have minus 4 times minus 2, minus 1 times 8. Simplifying gives us 8 minus 8, which equals 0. And whenever the determinant of a matrix equals 0, we say the matrix has no inverse, and secondly, the matrix is singular. So if determinant is 0, there is no inverse, and the matrix is a singular matrix. Note, the determinant of a matrix can also be denoted by this absolute sign and the matrix in between. Look at the lines, absolute. Now let's take an example on singular matrices. Find the value of x given that the matrix A below is singular. Find the value of x if this matrix is singular. For a matrix to be singular, as we have just said, the product of the leading diagonal minus that of the off diagonal must give us 0. That is, the determinants must be equal to 0. So we find the determinant and equate to 0. The determinant of this matrix will be 2 times x minus 3 times 4, which is equal to 0 because they said the matrix is singular, and that gives us 2x minus 12 equals 0. 2x equals 12, and dividing both sides by 2 gives us x equals 6. So for this matrix to be singular, the value of x must be equal to 6. Hey, thank you so much guys for watching, and we hope you stay tuned for many other videos. Bye bye.